I tell you, man, you just can't imagine back on that how many people in college start getting hooked. And I'm not kidding. They'll blow through. I'm not kidding. A lot of people. I say a lot. I bet I know at least 5 to 6 people who have blown through a semester of tuition and had to go back and talk to their parents and say, I just blew through tuition. And a couple of those parents were like, well, you're going to earn this back or blah, blah, blah. A couple of them are like, you're coming home this semester. I'm just saying it's just an addictive thing. You just got to be careful about. All right. So to repeat what I was saying, yesterday when we did Ramon sums, a couple things happened on all of them. Whether I was going from 2 to 10 or 1 to 6 or -5 to 12, I was always going from least to greatest on the x-axis or the time axis. And all of my functions were above the x-axis. And so all of my areas that I found, whether you were thinking about them as area or distance traveled or whatever, all of those areas were positive. And that's the first thing I want you to know about accumulation. When you accumulate area from left to right, anything above the x-axis is counted as a positive area. Okay? So like if my velocity is positive, right, and I integrate that velocity, I get a change in position. Well, that would be a positive position change. And then when I accumulate that amount, that's a positive value. However, if I go negative velocity, which means the velocity curve would dip down below the graph, right? Yep. If it dips down below and I accumulate from left to right, that area down there is negative. Are you with me? So as you go from left to right, anything above is positive, anything below is negative. So when you see an integral, if the smaller number's on the bottom and the bigger number's on the top, that's going left to right. Are you with me? Now, if I reverse that, everything gets reversed. So if I was going to go from like time 10 to time 2 on a curve, and it may not even mean time, it could be x10 to x2. Now, as I accumulate this way, anything above is going to be negative and anything below is going to be positive. And a lot of people like to just go, you know what, that's one more thing in my brain I don't like. So a lot of people like to just take the two values on the integral. So like if you're going from 10 to 2, they just switch them, just put a negative out front. And then they can always go from left to right. Does that make sense? But a lot of times what you're going to be given are tables or charts or whatever it is, or graphs or pictures like I just showed you a second ago. We're going to go through there and accumulate these areas. And remember, when you accumulate snow outside, if I accumulate 22 inches today, then clearly, well, most likely I'll have 22 inches on the ground minus whatever melted. But if I already have snow out there and I accumulate 22, my net amount is going to be way more than 22, right? So remember, when I'm accumulating, that doesn't tell me what I'm beginning with, okay? I'm starting with something, most likely, maybe nothing, maybe a negative amount, maybe a positive amount. But what I'm getting is a change in that amount. And I wanted to remind you about that again, and I did it at the top of page 93. Again, when I am accumulating, well, we just mentioned this. Not this one, right here. Go back to the top of 93. When I am integrating from A to B, and I integrate a rate, like acceleration is a rate at which velocity is changing. When I integrate acceleration, what am I getting?
A change in velocity.
A change in the amount of velocity, which would be a change in the velocity. Okay? If I integrate a velocity, I'm getting a change in the position or the amount of change that occurred in my position. Are you seeing that? And if but just make sure you remember the word change. A lot of people go, integrate a rate, get an amount. Well, that makes you think, oh, an amount. I know how much snow's on the ground. No, you know how much the amount of snow changed. You still don't know how much is on the ground. Fundamental theorem will take care of that in a couple of days. Yes?
If you started time 0, if it is one involving time, would it just be the total?
No, not necessarily, because like I could call time 0 right now.
Oh, I guess C being in existence now.
Yes. And that C, you will SEE the C start to mean something. And a lot of times your C might be something. Like when we worked problems already on the last test, when we plugged the 0 in and found C was 30, I think was one of the problems, right? I kind of told you there was an initial amount of 30, right? Now, you didn't even know what you were doing there, but you were literally kind of applying the fundamental theorem. You were just doing it in a way where we didn't address that it was the fundamental theorem. But when we get to the fundamental theorem, I'll throw it out there, you'll kind of see it. But just remember, when you integrate, you're getting a change in whatever it is we were talking about, okay? Not how much. That's different. And if you get that down now, man, you're going to be just accumulating points on the AP test left and right. Okay, so anyway, jump into what we're going to do here. I just kind of want to walk you through some of these. So if you see something like this, accumulation, integral of the function from 2 to 7, I'm heading to the right, right? From 2 to 7, I'm heading to the right. So any part of that function that was above the x-axis, since I'm heading that way, would be a positive value. And if it dipped below, any of that area between the function and the x-axis would be a negative, and I would just take that positive and that negative and add them together, right? But if I'm going from 5 to 1, now I'm going from 5 back to 1. If I do that, anytime the function's above that area is going to be negative, and anytime I dip below, that area would be positive because I'm reversing direction. And again, people like to take these sometimes and go, you know what, forget that. I'm just going to flip this, put a negative out front. Now I'm going from left to right. But I've already put the negative out front. Just don't forget in the end to multiply it through. So that is an option. So let's just take a look at some of these and see if we can make sense of this. All right? Now, whenever you see these, I know it might look elliptical. It might because it's stretched a little bit, but you can see that the radius is 2, radius is 2. So that's actually a semicircle. They do a little bit better job, but anyway, I stretched my curve out and didn't really think about that. But if you're finding area, does everybody know what an area of a circle is? Pi radius squared. So an area of a circle with a radius of 2 would be 4 pi, but this is a semicircle, so that total would be 2 pi. So let's see if we can figure this out. Right here it says, what is the integral of this function from 2 to 5? So I'm beginning here at 2, and I'm going here to 5. And no, I will not ask you from like 2 to 4, because 2 to 4, you're like, well, how do I figure that out? I mean, you can do it, but you would literally need to be able to integrate that, and we're not going to get into that. So right there, what kind of area do we have right here?
A triangle.
So 1/2 base times height is 1/2. So I'm going to have at least a positive 1/2 because it's above. And then the area from 3 to 5 would be what? 1/4 of the circle. And 1/4 of 4 pi would be pi. So I end up with 1/2 plus pi. That would be my area. And you don't approximate pi to 3.14. Just put pi. All right, what about negative 3 to 7? Negative 3 begins here. 7 ends here. So from there to there, what do I have going on?
That's 3 squares and 2 triangles.
So if you want to count them, you could just say 1, 2, 3, and then you have 1/2. So that's a total of 4. I could also use a trapezoid formula, couldn't I? 1/2 times the base times the sum of the heights. And that's a nice little trapezoid. So that right there ends up being a positive 4 because I'm going to the right. What does that end up being? This goes from here to there.
With a base of 1.
Are you sure it's at 1.5? No. How could you be sure? If I'm rising 2 and running 3, that's the same thing as rising 1 and running 1.5, isn't it? Now make sure about that because sometimes it'll cross at 2/3, right? It'll cross right there. And people just are suckers and they just don't, they're sloppy. But 8 people do that. They're not trying to be super nice, but they're generally not bad. A simple proportion will get you that value. Yeah.
Couldn't you just cancel out from -2?
Great idea. If you do see, he's saying right here, rather than calculate that area that's negative, right? There's the exact same area here that's positive. And because those two are opposites, why even bother calculating them? And I'm always looking for things like that that could actually save me a step. Now, I might have to come back later and figure that out, but for now, I don't have to. So far right here, I'm at positive 4. These two values would cancel. I already know that's a positive 1/2. And then I'm going all the way here, and what is this? 2 pi? So I end up with 4.5 plus 2 pi, or 9/2 plus 2 pi. And again, that's good. What about -6 to 2? So -6 to 2 takes me from here to there. So what do you have here? How do you want to calculate that?
Split it up into two things.
Okay, rather than do trapezoid, 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 I'd probably go, well, that's already 1, 2, 3. And then this is just a triangle, or 2 if you want to think about it. I'm just going to think about it as 1 and go 1/2, the base is 3, the height is 1, so 3/2. So what's 3/2 and 3? 4.5, but it's below. So far I have a -4.5.
Plus 4.
And then this is, again, 1, 2, 3, 4.
And then cancel off the rest.
And then that cancels again. So I have a -4.5 and a 4, so -1/2. All right, what about number 4?
Opposites.
So I'm going from 3 to -1. So here's 3, and I'm going to -1. So if I'm heading this way, now what is that?
Still just -1/2.
That's a -1/2. And then this negative area above and that positive area below would have canceled. So -1/2. Y'all seen it? Now, again, what I talked about earlier, if you don't like that, I can do this. I can just switch the 3 and the -1, put a negative out front, and now I'm going from -1 to 3, right? Which would give me this negative area canceling with that positive area, and then a +1/2 left over. So I would come in here and say, all right, this is equal to a -1/2. Don't forget the negative, though, which again is -1/2. I don't think it's really necessary to do that, but I'm just saying you can if you wanted to. It's not like these rules are that complicated. All right, what about 2 to -3?
Negative again.
So from 2 to -3.
Just -4.
So again, these cancel. And then that we found was 4, but since it's above now, it's a -4. What about -1 to -6?
Still canceling out.
So -1 to -6. That becomes a what? That's a -4. And what was this? Before it was a what? -4.5. So now it is a +4.5. So +1/2. And then I had you look at number 7. It says calculate -6 to -3 and -3 to -6. It said, do your answers to the pair of the definite integrals number 7 lead you to think anything? So what happens when you switch those two numbers? It just negates whatever the value is. So just pointing that out, that is an option for you moving forward. And I see people that like to do that to kind of be consistent. Now, guys, there's nothing overly difficult about this, but yet people I really do feel like you'll do fine on this if you just are careful, but it's very easy to kind of get uncareful, I guess. All right, check this one out. Here's a very AP looking question. And they would usually preface this question, and they would say something like, the figure below is created by 3 line segments and a semicircle. So you would have confirmation that that is a semicircle and then segment, segment, segment. And they say complete the chart for big G. Now they like saying this. They're saying big G is equal to the integral from -2 to x of g of x. And this is G. So if I integrate G, I get the big G amount. So if I want to find, for instance, if x is -7, this is me finding big G of -7. So big G of -7 is saying, what would the what? What would the area under the curve be from -2 to -7. Now here's your -2, and there's your -7. So I'm heading that way. So what areas do I have first? Right here. That's an area of what? That is a negative pi, because it's 1/4 of the circle. The circle's 4 pi, right? Pi r squared. And it's 1/4 of that. But since you're heading left, anything above is a negative. And then what is this? Base 3, height 3. So 1/2 of 9, right? So 4.5, but it's also negative because it's above. So from -2 to 7, that means g of -7 would be -4.5 minus pi. Now, what if I found g of -4? So g of -4 just goes from there to there. So what does that end up being? Just a negative pi. What about g of negative, and stop me at any second if I'm going too fast. What about g of -2? 0. Does that lead you to a conclusion about any time these two numbers are the same? If they're ever the same, it's equal to 0. And when we do the fundamental theorem, or if you take physics and you've already been calculating these, you're like, oh yeah, of course it would, because I got this function and I'm plugging the same number in and I'm subtracting them. I'm going to get 0 every time. So yes, that would be 0. And then what about if I'm going to 0? Again, I'm starting at -2. I'm going to 0 now. So this gives me that direction now. So that now it's above, now it's positive. What about at 2? Now here's where you got to be careful. This is where the geometry comes into play. There's 2. What do I have to do to find that?
Find the bigger one.
Find the what?
The bigger one. Couldn't you use a proportion?
Couldn't I?
Use a proportion.
Yes, that's what I'm going to do, is use a proportion right here. This is a similar triangle to that, right? So use a proportion. You don't got to get all technical and figure out slope and all that kind of stuff. It's just well, it kind of is that, but you could say, well, the big triangle has a 3:1, right? And the smaller one has a 2 to, I don't know, or a 2 to y, if you will. So what does y end up being?
2/3.
So you're going down 2/3, right? So if that's a length of a 2/3 right there, then what would be the area of this triangle? Right here, this little part right here. 1/2 base, height, which ends up being 2/3. Are we good? So this 2 ends up being what? Pi minus, because it's below, 2/3. So far, so good? What about to 4? That brings you all the way to here. To me, it's easier just to go back and redo the triangle, right? 1/2, base of 4, height of 1, so 2. But it's below, so what? Pi minus 2. And then if I go all the way out to 5, what am I doing? Adding an additional 1/2, but positive. So if I add a 1/2 to this, pi minus 3/2. Now, a lot of you noticed, you're accumulating. You're adding on to what you have. You make a mistake right here at -2 or here, and you start continuing to add on to what you have, every single thing is wrong. So really be careful on your work and make sure that you slow down. Again, there's nothing overly impossible about this. Just slow down a little bit. Okay, what about, let's check this thing out. Tell you what. I don't want to. Now we'll do it. We're going to jump back to what we were doing before. So here we go. Calling this the skunk problem. All right, so a student is speeding down Route 11 in his fancy red Porsche when his radar system warns him of an obstacle 400 feet ahead. So there's something in the road 400 feet ahead. He immediately applies the brakes, starts to slow down, spots a skunk in the road directly ahead of him.
And speeds back up.
Okay? So suppose that the black box in the Porsche records the car's speed every 2 seconds, producing the following table. Assume the speed is decreasing throughout the 10 seconds it takes to stop. So I guess he's going really fast. Okay? A, using the information in this table, what is your best estimate of the total distance that the student's car traveled before coming to rest? B, which statement below can you justify from the information given in the story and the data in the table? It says, 1, the car stopped before getting to the skunk. The black box data is inconclusive. The skunk may or may not have been hit. 2, the unfortunate skunk was hit by the car. Now, what am I giving you in this table?
The velocity time.
Pretty close to velocity, but it might as well be velocity because the velocity values were always positive. And if the speed value, though, we could have been curving, right, on a road. So they said speed. So you can think of this linearly, even though he might have been doing something like this, right, or maybe even doing something like this on the road. But speed is going to give me distance when I integrate it. Velocity gives me change in position. So right now, did y'all hear that? If I integrate speed, which is always a positive equation, I'm going to get distance traveled because I never end up having any negative accumulation. If I integrate velocity, however, I may or may not get distance. I might get distance traveled. Like, look, if my velocity is constantly changing and I'm integrating this function right here, I went the same way. I'm just adding up a bunch of positive values. But if I have a velocity equation where I'm going positive and then back negative and then positive and then back negative, I'm going to be accumulating positive distances and negative distances, and they're going to give me a smaller change in position. So remember that. Integrate a V, you get a change in your position or location. I think in physics you call that displacement. Okay? If you integrate speed, when you integrate speed, because speed is always a positive version of the velocity, you're always going to get just total distance traveled. That would count positives and negative movements as all positive. So this is speed. So let's look at this. What's your best estimate? Now, what would you use? Which of the estimated products out there would you use that you think would be the most accurate for this? I don't think I told you to use a particular one.
Trapezoid.
Trapezoid? Okay, so if we use a trapezoid, which I tend to like trapezoids, trapezoidal accumulation, this is part A. So the integral from what to what? From 0 to 10 of my speed function, s of t dt, is approximated by what? Now, how many little sections am I going to have here?
5.
So I have 5, and each formula for trapezoid is 1/2 times base times sum of the heights. And what are the bases here? Every 2 seconds. So if I want, I can set it all up. 1/2 base, sum of the heights. 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 And my bases for all of these are 2. Makes my life a little easier because that's going to cancel all of those 1/2s. And then what is the sum of the heights? So 180, an 80 and a 50 and a 25, a 25 and a 10, a 10 and a 0. And if you remember what I said yesterday, do you remember that formula that if the bases are all the same, what you could do? You could factor out the 1/2 and the 2, and then do what? Which, by the way, cancel. And then do what? use the first term once, and you'll notice every other term shows up twice. So 100 plus twice the 80, twice the 50, twice the 25, twice the 10, and then the 0 once. Just makes your life a little bit easier. Is it really worth wasting brain cells on that if it doesn't come to you naturally? I would say no. You'll see my setups are almost always like this. If it's an old key, this is actually an old key that I have, and I used this. But in my experience, most people have more luck kind of doing this. So if you see this on the homework, you totally could have had that, or classwork or whatever. So what do you end up with? 100 plus 160 plus 100 plus 50 plus 20. So 360 and 70, 430. We got a dead skunk.
Yikes.
Okay? So we almost did it, but the last 30 feet, unless the skunk was high stepping out of there, he got plowed since he was 400 feet ahead. And hopefully he's not a completely stupid skunk and he sees something coming, he runs, scuttles off, right? But you never know, man. I was riding home from junior high once. I used to have to get in the yellow school buses. And I remember just sitting just bored, looking out the windows. We were coming home. And this is broad daylight, and we're driving down Carter Hill Road in Montgomery. And there's a big embankment, like on the side of the road. And then there's the woods. And out of the woods, like 100 yards ahead, this possum comes out, just trotting towards the road. And I'm like, surely he's going to stop. And he just literally ran up the hill like he was on a suicide mission, and just ran up the hill. And then, you know, he gets close enough, you can't really see him, but you just felt dun, dun, on the back. You're like, unbelievable. Like, who does that? So you never know. In fact, I had a friend of mine was driving down the road on 119, and just driving down the road totally freaked him out. He's cruising down the road, and I mean, out of nowhere, wham! Something hits the side of his window, and he barely holds on. And he stops the car, and he's like, what just hit me? And he looks out, and there's this massively dazed deer that just came sprinting across the road. He didn't even see it come out of the woods, and runs into the side of his car. Heck, my own dog. Back when my kids were really tiny, I'm putting like the ivy up across the door, you know, for Christmas, and the door's open. And my dog was a spaz. Anything not our family, she just took beeline. It looked like she was trying to kill someone. She would just take off. She was really fast. She goes sprinting out the front door. And I'm like, and there's this little old lady walking across. She's, well, not little old, but she's like probably 55, 60, near my age. But she's kind of frail, and she's kind of cruising across the street on the other side. And my dog is sprinting towards her. Well, here comes my mother-in-law up the top of the hill, all my kids in the car, and my dog runs into the side, literally hits face first into the front wheel as she's driving. Of course, the rubber kind of grabs her, and I was like, my dog is dead. Right there, my mother-in-law ran over my dog. And my kids are in the car. How traumatized. And miraculously, she got up with like major abrasions. But anyway, you never know. Hopefully the skunk got out of the way. Jesus. I remember I just repaired, spent like $450 sewing up her nose. She run away and came back with like this massive gash where she got in a fight with a possum or something. Probably not that one, but she normally won her fight. She was a pretty mean dog in the neighborhood. Great with people, but horrible with other dogs. But this one, she was just tattered. I mean, you could see like ligaments. You could see like separation on one of the little pads was almost removed from that car. I just taped her up. They're shocking how quickly they can heal.
Take her to the vet?
I didn't. I was like, I had just dropped $450 on this nose and this big cone she had to wear. I was like, I'm done with this. I wasn't a real big fan of her the first couple of years, but we bonded later.
That sounds like animal cruelty.
No, I didn't. I bought a ton of Neosporin and a bunch of gauze, and I just gauzed her whole arms and every part that was abrased, and just gauzed it all up with Neosporin. And shocking how well dogs heal. I mean, it's amazing. It was like it didn't even exist when I untaped her a couple days later. All right, here we go, guys. So rate at which water flows. Great AP question right here. Stay with me. The rate at which water flows out of a pipe, all right, is measured in gallons per hour. So this is a rate.
Oh.
Okay. It says it's a differentiable function. What does that mean if it's differentiable?
Find the derivative of it.
That's true, which means it's continuous with no corners, cusps, or other foolishness, right?
Vertical absence.
Okay, so these are things you got to pick up on because they could mean something later. And I think I left out part C, but I might remind you, I might remember. So I'm measuring it every 3 hours. So they were nice enough to give you consistent intervals here. They don't do that as much anymore, but they did here. And it says, using a midpoint Riemann sum with 4 subdivisions, that handed you that part of the question, of equal length, approximate the integral of the rate from 0 to 24. Well, there's your 0 to 24. Now, remember what we do with midpoints.
Skip numbers on the table.
Yeah, because on a midpoint, what I really want to do is take the time in between there, the 1.5, and take the rate at 1.5, but I don't know it. So I have to skip over that and use the rate from the 3. Skip over that, use the rate from the 9, skip over that, use the rate from the 15, and skip over that. And in this case, at least it makes sense because the number in the middle is actually in the middle, but I do have its rate, and those are your 4 subintervals. But now my bases are no longer 3. What are they?
6.
And you can see the bases are 6. So using a midpoint Riemann sum, so what do I write? The integral from 0 to 24 of this rate, and don't use f of x if they define it as r of t. All right, so I'm integrating that rate function. Don't forget the dx. And what do I do with midpoint?
You just take the
base,
middle,
which is 6, times the
middle
height in the middle, which is 10.4. So 6 times 10.4, 6 times 11.2, 6 times 11.3, and 6 times 10.2. So I get what? 62.4 plus 67.2 plus 67.8 plus 61.2. And I add that up and I get 2.
I don't think I understood what you said there.
Is that right?
Yeah.
That's right.
Yeah. So 256.8 what? So when I integrate a rate, I get a change in the amount. So right here, the amount of water that was in this tank, okay, or behind that pipe, the change in the amount was that, okay? So if there's a big tank, I don't know how much water's in the tank, right? I just know how much is now, I guess, in my new container in this 24-hour period. Now this right here, is there some time, this is a great little question, is there some time where the derivative of the rate is equal to 0? Now think about that. The derivative of the rate would be the rate of the rate. That's almost like an acceleration kind of thing. You're nodding yes. Why? If you get this, I'm so proud. If you don't, I'm still proud.
Now I'm less confident about it.
I want to hear it.
What's your rhetorical?
Come on, man. Talk to me. Well, how do you know for certain? Yes.
Because it approaches a maximum and it starts going down again. And on a velocity graph, if thinking about it as velocity and acceleration.
Forget velocity. Think about it as any function.
Any function, when you integrate it, the maximum is a point where it goes from increasing to decreasing, meaning it's 0.
That's great. Is there even better way? That's really good. Do you hear what he's saying?
Sure.
He's saying if this is a function and I'm going from lower values to higher values and back to lower values, and it's continuous, which it is, and differentiable because it says it's differentiable. So if it's a continuous function, then I know it's doing this at some point, right? But what rule do you have that guarantees? You're getting closer. What guarantees a slope of 0? Rolle's theorem. What does Rolle's theorem say?
It says
if the y values at any place are the same, then you are guaranteed to have a slope of 0 on a continuous function that's differentiable in an interval. But you're right. You could have explained that and said, yes, if I'm going from increasing to decreasing values, I'm guaranteed to have a max at some point. That's the extreme value theorem. And it is continuous. It said it was because it's differentiable. But Rolle's theorem is kind of the way to go. Or you could say, quote, mean value theorem. Because the slope from beginning to end is 0. I know that there's a slope of 0 somewhere.
So if you have to explain that, do you just say according to Rolle's theorem, or do you have to explain what Rolle's theorem is, show that you know, or?
I tend to be a little more paranoid, and I tend to do both. I tend to say Rolle's theorem is met because the initial and the final rates are the same, so you're guaranteed to have a slope in the interim from 0, in between 0 and 5. How are we feeling? Okay, so we've talked about accumulation and approximation. We're going to keep doing this a little bit, and we're going to start working in FTC. And then we're getting close, guys. Getting close.
No, but I forgot it. Oh yeah, because like what did we do? Like I just
Hey Gabe, I have your physics homework. Discover dark matter and study it.
That's so lay down.
Upside down. There's so many better words to use.
You gotta trust the process.